Okay, in this video we're going to have a look at using the minimum and maximum values that we found from completing the square to help us answer a few more complex questions. So if I took a function of x, which from my previous video we looked at this function x squared minus 4x plus 7, we completed the square to give us x minus 2 all squared plus 3, and this told us when we sketched the curve that the minimum value of this curve was 3, and that happened when x was 2. So what we're going to do is we're going to use that to try and find the maximum value of 1 over x squared minus 4x plus 7. So you notice the denominator here is actually the same as f of x. So this fraction that we're looking for is 1 over f of x. Now, if I want to find the the maximum value of a fraction, I want to be dividing by the smallest possible answer. So I want it to be divided by the minimum value of my function of x. Now fortunately I found the minimum value from the previous video, that the minimum value is 3, so this is now 1 over 3. So 1 over 3 is the maximum value of this fraction. If I follow that through, if I wanted to find the maximum value of 1 over x squared minus 4x plus 9. Well, if we compare this expression with our original function f of x, you can see the x squared is the same, they've both got minus 4x, but the unit is 2 more. So this is the same as our f of x plus another 2. So if I want the minimum value of this division, this fraction, so it's the maximum value of this fraction, I want the minimum value on the bottom. So I need to take the minimum value of f of x, and then I'm going to add 2 to it to match up with the add 2 there. So the minimum value of f of x was 3, so this is going to be 1 over 3 plus 2, which is 1 over 5. Similar way, I can find the maximum value of 1 over 2x squared minus 8x plus 14. So if I have a look at this expression on the bottom and compare it to my function of x, then this function here is twice the size of my original one. So this is 2 f of x. So if I want to find the maximum of this, I want to be divided by as small as I possibly can. So I need this f of x to be as small as possible. So I'm going to be doing 2 times the minimum value of f of x. The minimum value of f of x was 3, so this is now 1 over 6. Okay, if I tried another function, if I tried g of x, so g of x, if I take a negative x squared this time, negative x squared plus 4x plus 1, then from the previous video, this completes the square to minus x minus 2 all squared plus 5. So because it's a negative quadratic, so this is an n-shaped curve, this gives us a maximum value. So our maximum value is going to be 5, and that happens when x is 2. So if I wanted to find the minimum value of 1 over minus x squared plus 4x plus 1. If I look at the denominator and compare it to what we have up here, this is actually g of x. So this fraction is 1 over g of x. And if I want the smallest possible value of a fraction, I need to be divided by as large a value as I possibly can. So I need to be divided by the largest possible, so the maximum value of g of x, which we worked out here, is 5, so this is 1 over 5. If, say, I wanted to find the minimum of 1 over minus 3x squared plus 12x plus 3, here I compare this to my original function g of x, and you've got 3 times as many x squareds, 3 times as many x's, and 3 times as many units, so this is 3 lots of my original function. So if I want the minimum of this division, I want it to be divided by the largest possible term that I can. So I need to do 3 multiplied by the largest possible, so the maximum g of x that we have, and the maximum from g of x was 15, so it was 5. So I do 1 over 3 times 5, which gives me the 15. So I get 1 over 15. And that's it.